Hey everyone, this is Benjamin. Welcome back for another IoT video. It's been a while, maybe a couple of years, I think, since I came on that channel last. But yeah, I'm happy to be back. And today I want to talk to you about the Zephyr real-time operating system, and I want to show you how to actually use it on this developer kit, which you've seen me use in the past, either here on the channel or on my blog. It's the Azure IoT MXChip developer kit. So if you've been playing with Microsoft Azure IoT in the past, more recent past, or pretty much from day one, actually, this is the dev kit that Microsoft has been using to showcase Azure IoT scenarios. And I thought it would be a good idea to make sure that this is something that actually plays well in the Zephyr ecosystem as well. So what is the MXChip IoT DevKit? It's an Arduino kind of device. It's an embedded target, which has tons of interesting sensors for barometric pressure and temperature and humidity and whatnot. It has an LCD display as well, which I'm a huge fan of, as you've seen me say many times, but we're actually going to show it in the demo. And this particular device, usually you would program it using something like the Arduino development environment, which helps you write an application that doesn't have to worry too much about the hardware details of like what is the sensor, what is the memory layout and whatnot. But it also has some limitations in that it's not really a full-blown operating system, which Zephyr is. Zephyr is a real-time operating system which helps providing even more services and more levels of abstractions when it comes to writing an embedded application. One thing that you may want to do is make sure that you program your app in a sort of multi-threaded model, something that's not necessarily straightforward with embedded, but that a real-time operating system such as Zephyr allows you to do. You may want to have, you may need to store some information in the memory of your device. What if you'd had an actual file system to do so? So that's the idea of a real-time operating system. That's the idea of the Zephyr. And today I want to show you how I went essentially through the getting started, which you will find on the main Zephyr documentation website and as a link in the description of the video. The documentation actually has a really nice getting started guide, which I already went through to set up all the prerequisites for Zephyr development, which is checking out the source code, installing Python, setting up a Python virtual environment, like this kind of stuff. And once that's done, then you can effectively start doing things like running the different sample applications. We have hundreds of those. And one such sample is sort of the hello world of embedded, which is blinking an LED. It's called Blinky, and building Blinky is as simple as going into your Zephyr main folder, which is like I'm already in it in this shell environment. And so it contains all the source code of Zephyr, including the source code of the sample applications. And building a sample application is as simple as issuing the west build command -p as in pristine. You want to make sure that your build folder is going to be cleaned every time you're building a new app. Then which board you're aiming for. And like I said, there's tons of boards. You can actually see it here, the hundreds of boards. Like we can actually filter all the ones from, say, ST Microelectronics. You will find some familiar names maybe in the list, but in my case, the one that I care about is the AZ3166. Yes, it's there. So I can target it when I west build my app. And essentially, let's just, complete from the history. West build pristine, -b as in board to indicate which board we're aiming for, which application. So in my case, the root of the application folder is samples /hello world. And then as soon as it's built, I'm actually going to flash the board. So we have the IoT DevKit over here. Right now, it's doing pretty much nothing. So I'm going to build the app. flashing the app. And now we have a, oh, did I build the hello world? I did. I should have built the Blinky. Building Blinky. And there we go. And we have the user LED, which is right here. It's blinking. So that's the typical hello world. Maybe we can quickly and briefly look at the code actually. So this is my VS Code environment, and this is the source code for the Blinky application. And this is typical Zephyr code where we use something that's called the device tree to get the handle, if you will, to some resources that are that make up our device. So one such resource is the LED 0, which is attached to a particular pin, and the pin is configured based on whatever hardware we're running on the MXChip DevKit. It's effectively an STM32 Cortex M4 MCU, but it doesn't really matter. The Hello World, or the Blinky in that case, doesn't really care about that. It only cares about the higher level of abstraction, which is, oh yeah, we're going to have a peripheral that's called LED 0, and we're going to configure it, making sure that it's set up as an output. And then we're going to have some code that's effectively an infinite loop where every second, or is it every second? Yeah, every 1,000 millisecond, we're going to toggle the pin that corresponds to the LED, and that's it. That's the app. It's 100% portable, since you can see that it has no dependency whatsoever towards the MXChip DevKit. So that's for one sample application. Like I mentioned, we have an LCD display as well. So what if I were to build for this one? So I think it's living somewhere in the display subsystem. Yes, and it's called the character frame buffer. So there's an API that allows to manipulate an abstract notion of a screen. And this is what we're going to flash, build and flash. And this one is going to interact with the LCD display. There we go, the display. Here, the LCD display is showing fonts, and it's being refreshed as quickly as it can. So that's it. Again, if we were to look at the code, it has no dependency whatsoever towards the MXChip DevKit, even to the point where it's not even like the code doesn't care or doesn't have to care about the size of the screen, the resolution and things like that. It's already taken care of and abstracted out in the again in the device tree. Another sample, the MXChip Developer Kit, has some cool sensors on it. It might be good for us to use this as a way to see how things work when it comes to sensors in Zephyr. So let's look up at the different samples for sensors. One is the so-called sensor shell. This one is going to be really cool because we're going to be able to actually use our serial monitor, serial interface to talk to the device just as if it was a Linux command line, pretty much. So it's going to be pretty cool. Building the app again. Okay, so the app is built, it's running. Looks like the LCD display is not displaying anything. The LED is not blinking, but surely another app is running. So we're going to check it out. Maybe before, one thing that I wanted to show is when we built the app, there was this interesting build output that says and tells us how much flash, how much RAM the app consumes. I can actually go slightly further. If we want to sort of troubleshoot, if we feel like this is too much for some reason, we can actually know where what's coming from where in terms of the footprint. So there's a bunch of command to get a RAM report and a ROM report in terms of essentially what's the usage, what's the RAM usage coming from. And here we can see that 4Ks and a half are actually coming from the UART shell. So maybe when we're finished troubleshooting our app, and we realized that for production we don't need a UART at all. Well, we know that we can actually save quite some memory there, right? And similarly, we could see all the different drivers, all the different peripherals, how much they're eating up. Like the sensor drivers, they don't seem to require a lot of RAM, but maybe they do require some RAM. Let's see about that. So let's see the sensors. Yeah, they must be there somewhere. I should probably grab the output, but I mean, you get the idea, right? Like how much my hardware abstraction layer is eating up, how much, here they are, the drivers. So this particular accelerometer sensor, oh yeah, 300 bytes. This one, oh, it's much bigger. Maybe something's wrong there, or some functionality. Maybe I want to disable to save some space if I need to, and if I want to. But that being said, the app is built, it's running, and it's a sensor shell. So a sensor shell means that we probably want to interact with it through a terminal, serial terminal. Let's see, do we have a shell? Yes, we do. So this is the Zephyr shell, and so we can do a lot of things, like maybe getting some info regarding our device, or maybe more. Let's see. Device was good actually. Device list. What's the list of all the peripherals that I have? Are they working? Maybe I can issue some commands with regards to the kernel, like what is the uptime of the Zephyr kernel, blah, blah, blah. But then what I'm particularly interested in is the sensor sub shell, if you will. So sensor sub shell, what does it have for me? It has something to list to get info regarding the sensors. Oh yeah, I have a bunch of sensors. What if I were to issue sensor get? And for for this guy, I can in real time get the temperature of the sensor, right? And that's actually pretty cool, because you would do the same in your application. You would be getting a handle to the device tree description of the sensor, and then you would retrieve the ambient temperature as an ambient temperature, and not just as a random integer in some obscure register, which you need to convert back and forth between. I don't know, like, you get the idea. Here it's really abstracted out, and through the shell you can actually also do a lot of troubleshooting without even having to write code actually. So that's pretty cool. And let me think about it. Yeah, I think that's pretty much all that I wanted to show you. There might be some other samples that you will find interesting to run to get familiar with, I don't know, maybe PWM. You want to blink the RGB LEDs using PWM, or you want to get more familiar with the kernel primitives for semaphores and multi-threading, etc. You will find examples around that too, maybe in the threads section. But yeah, I think that's what I had. Trying to think if I didn't forget anything. I don't think I did. I think I actually wanted to show you the very same app running on this particular board, but I mean, there's nothing to show really. Like the app that we had earlier, right, where we were having characters scrolling on the screen. The same app is running here with no code change whatsoever on the e-ink display, but that's the same app, the same code. So yeah, check it out. Like, check out the getting started. If you have any questions, you know where to find me in the comments on the YouTube video, on my blog, on Twitter, whatever. And I really hope that if you have an MXChip somewhere on your desk or in your drawers, you will dust it off, try it out, and let me know what you built. See you next time.